Thank you very much. So to everyone, welcome to the session Microservices with Dapr on Azure. First of all, I would like to thank the sponsors that make this event possible. And what are we going to learn today? I would like to give you a brief introduction to Dapr. We'll see some sample application developed with Dapr, and we'll see how Kubernetes can work with Dapr and how an application can be integrated and deployed to Dapr. Then we'll focus on the main topic of today, which is Azure API Management integration with Dapr. I'll do my best to answer your questions at the end of the session. So I already mentioned the acronym Dapr a few times, but what does it mean? So it means Distributed Application Runtime, a portable event-driven runtime for building distributed application across cloud and edge, and we'll try to understand what this means. A little bit about myself. I'm a cloud solution architect in Microsoft. I talk a lot about Dapr because I really love it. I feel like I spent my professional life as developer and team leader waiting for it. Because of my interest, I had the chance to write a book about it, Practical Microservices with Dapr and .NET by Pact. So let's say a fictional company is looking to implement an application like this one, which by the way is a sample from my book. And they are evaluating microservice architecture as everyone else. What are the challenges they face in developing and deploying it? Well, enterprise developers need to balance between the desire to deploy application in a scalable, flexible way and the need to be efficient in resource usage and costs. The focus of developer is less on the infrastructure and more on creating new application, possibly using multiple languages and frameworks. As Microsoft, we noticed that customers face some common challenges in developing with microservice architecture. Sometimes it is the toolchain that does not address all the needs to build a distributed application. Other times it is the runtime that restricts the feature set or the portability. And this is the context that Dapr wants to address. So Dapr offers a set of building blocks that express the best practices Microsoft learned in creating solutions and offering service. It is a runtime that can be used by any language or framework by interacting with a consistent set of easy-to-use API built around existing standards. The components used by Dapr can be configured also to adapt your solution to the deployment environment of your choice. And Dapr is an open source project started by Microsoft and driven by an active community. The process to donate the Dapr project to the Cloud Native Computing Foundation has already started. The Dapr building blocks, these 7 on screen, can be used all at once, or you can apply just the ones you need to your solution. And Dapr runs as sidecar alongside your application and can be used by any language and framework as long as it can interact with HTTP or gRPC API. While you can interact directly with Dapr via the API, a set of SDKs for many languages are provided directly by the Dapr project. And Dapr can operate on any cloud or edge deployment, as Kubernetes can operate everywhere. So Dapr adopts the sidecar pattern. What does it imply? Well, it means that our application can always count on the presence at a local endpoint of an API that is ready to fulfill all our requests, whether this is a call to another service, retrieving a state, publishing a message, reading a secret. And depending on the hosting platform of Dapr, the sidecar will have different forms. On a VM, such as my development environment, it will live in a local process aside from my application. In a Kubernetes cluster, this sidecar will be a container instance living inside the same pod. Of the building blocks of Dapr, I will talk about service-to-service invocation and publish-subscribe that enable Dapr application to interact. State management to persist information in a store with a common set of API, actor because it's my favorite building block, and during the demo, I will gain, hopefully, your trust with observability building block by showing that something is really happening. So Dapr out of the box offers a vast list of components for each building block, supporting generic options, Azure native services, and services from other clouds too. The components used by a Dapr application can be swapped by changing a YAML configuration file. Let's start with the service invocation. So with service invocation, if I want to call a method of another application, I just need to call the Dapr sidecar serving my application, specifying the name of the application I want to reach and the name of the method I want to invoke. And then I will pass my payload, in this case, hello world, nothing more than that. It will be Dapr responsibility to discover where the application is hosted and provide a secure encrypted channel toward the corresponding sidecar, wherever it is running. This, in turn, will invoke the application I intended to reach and return the result back. If I need to persist a piece of data or information, I rely on state management. In a similar way, I invoke the Dapr sidecar, and here I specify the name of the component corpdb and the key of the element of information, the piece of information I'm trying to retrieve. Apart from the detail of the API you can work with in managing the state, I want to focus on the YAML configuration. Here you can find that corpdb is the name of the component, and I specified that the type I'm using is state.redis. In the metadata, I have specific settings that applies only to Redis. So what happens if I want to change the component from Redis to Azure Cosmos DB? Well, from the point of view of the application, nothing changes. I will use the sidecar in the very exact same way. What changes is all in the configuration. So I have the very same component name, but I changed the type. So now it's a state.azure.cosmosdb, which obviously have a different set of configurations. But nothing more than that is necessary, and this applies to all the components. Well, publish and subscribe is a different approach to send messages or events from one application to other, whether this is to postpone the processing of information, or I even do not know the full audience of the application that are interested into my information. So in the same way we already learned, I can interact with the Dapr sidecar and send push as my payload with a post specifying the name of the publish and subscribe components and then the name of the topic. It will be the Dapr sidecars running everywhere that interact with each service, and they will ask to the service if and they are interested in subscribing event and which topic they are interested in listening to. So here we have service A and service B that are both interested, and the Dapr sidecar will learn how to call them to process the message. Well, with the actor building block, Dapr implements the virtual actor pattern. So actors are stateful objects of storage and compute that lives together. Dapr manages the distribution and the failover of the potentially vast population of actor instances among the hosts or pods if we are describing a Kubernetes deployment. Access to a single specific instance of an actor is turn-based. Well, that means that any other concurrent request to any of the actor instance methods isn't queued and fulfilled at due time once the current call completed. Actor have a specific way of managing state, and Dapr handle the overall life cycle of an instance, providing timers and reminders that are useful mechanism to schedule recurring or delayed activities on the actor instance. So how do I use the virtual actor building block, the actor building block in Dapr? Well, I interact with my Dapr sidecar to reach, in this case, the actor instance with the key A of the actor that has type my actor, because I can have many different actors in my application. And I ask my sidecar that once it finds this specific instance, it has to call the method update and pass a payload. So these things change a little bit compared to publish and subscribe and obviously service-to-service invocation, because we have the participation of the Dapr actor placement service, which maintain and distribute a map of the partitions of my actors in the various hosts or pods. In this case, my sidecar will learn from this map where to locate the actor A of the type my actor. So distributed tracing enable you to understand how your system, how your application is doing. And we agree that it is necessary to operate it successfully. You should be able to observe the calls happening in your application, reading the performances, and hopefully noticing issues before or as they occur. Having to maintain this code, which is not part of your core logic, is another unnecessary tax on the developer. And there's even more complexity. So if you wish to consume the intelligence gathered from your telemetry in a specific service, for example, it might be more difficult in a microservice architecture in which many languages are present. So you might have different versions of the SDK to maintain. As with any of the Dapr building block, you do not need to keep using frameworks and libraries in your code. When you build an application, a solution with Dapr, all the interaction between the different Dapr application flows through the sidecar. So which via configuration can be instructed to collect metrics and send it to other external services, or in my case, I'm using Zipkin. So in this area is a case of standard adoption because Dapr adopts OpenTelemetry, and with the collector, it can send data to all the telemetry services you can wish for. Dapr provides also metrics for monitoring how the Dapr sidecar control plane or system service, as you wish, behaves. So what is the call latency, how much memory and how much CPU is using. Also, you have to consider that in Dapr, most of the network interaction is performed by the Dapr sidecar. So this kind of metrics will be even more interesting. So Dapr has two hosting environments. The self-hosted is really easy to use. It's what you do once you start developing, and it works with Docker images. And a Dapr sidecar is a process that gets created once you use the command line interface of Dapr with Dapr Run. It's very different when you host Dapr in Kubernetes. You can obviously install it with Dapr init -k, but you can also use to deploy and upgrade the Helm chart for Dapr. And there is a Dapr control plane, which one of the first objective is to inject, to place Dapr sidecar into your application pods. If we look how Dapr configure itself on Kubernetes, we see that few system components are present. So we already met the actor placement service. Then we have the injector, which has the role of positioning the Dapr sidecar in the deployments that are requesting it. Then we have the sentry, and the sentry role is to create a secure channel between the services. Then we have the operator, which manages the configuration of components, etc. So if we go back to the fictional sample application, how would it look like if I implemented with Dapr? So this is how potentially our solution could leverage Dapr, split between multiple applications, all communicating one to each other via service-to-service invocation or publish and subscribe. I decided to use the readily available components of Azure Service Bus for publish and subscribe, and the Azure Cosmos DB for state store, wherever information needed to be persisted. Azure Cosmos DB has been also the choice for the actor state store. I added the actor building block to keep the stock keeping unit under control for a fast stock management. So let's have a glimpse of how I can describe an application to be configured with Dapr. So if I have here a typical, simple, very basic deployment of a containerized application. In this case, I placed this order service, which is one of the components of our solution, into this container, and I placed it on Docker Hub. So it's really basic. There is nothing more other than deployment. Please note that there is no service here. Well, most of the configuration is in this part. These are the annotation that tell Dapr that I'm interested and I'm asking to Dapr to place the sidecar into my pod. And I will make my application reachable to all the other Dapr application with the name order service. Then I specify other settings. One, for example, this one is the one using a configuration that will enable us to see what is happening with zipping. And then we have many more settings to configure not only the requests and limits of my own container, but also the resource request and limit of the Dapr sidecar. If we look at the cluster, so this is my Azure Kubernetes Service cluster, well, you can see that there are few components that are the ones that I showed in the schema before under the Dapr system namespace, and we see the order service. If we take a look at it, we have just one pod here running because I keep my node count very low. And here is the container that I configured. I named order service. I did not configure in my deployment the presence of this container, which is the sidecar, it has been Dapr that placed it here. Okay. So let's see for the ingress, because in the if I wanted to expose my applications, I had to find a way to make them reachable from the outside. So I decided at this stage to use Nginx. And so trust me, there is an ingress controller already configured. And here I'm showing you the ingress rule. So here I'm saying that anything that reaches the /order will be rewritten as this familiar path, which is the one that you need to reach the sidecar, and the service name for the backend is going to be the name of the service I have readily available in my Nginx pod. So this is the name of the sidecar. So for example, if I try to invoke, I'm using here Postman. So this is just a host name for the corresponding IP. And I invoke the order via the Nginx. If we try to see what is happening via Zipkin, there should be something here. So if we can take a look at it, we'll see that the root of this trace has been Nginx, but I did not configure anything specific in Nginx to send data to Zipkin. And well, as we saw, we just leveraged the presence of the sidecar to send, to pass the request back to order service from the request our ingress controller received. And I do not want to spend time here, but you can see that Nginx passes to order service, then order service interacts with state, and then publish an event. This event is received by reservation service, etc., etc. Okay. So we let's observe the solution that I briefly describe once again. So the request comes from my clients through the ingress controller, and this ingress controller has been Dapperized, has been enabled with Dapr. And everything is fine. I have no complaints, also because I built this sample. But I feel like there could be something more versatile than Nginx to expose my API. So, and here comes Azure API Management. So Azure API Management is an Azure platform service that enables you to expose, protect, and manage the API. Is made of three main components. The API gateway is the endpoint that accepts your calls, well, your customer calls, and routes them to the backend. It can verify API keys, token, certificate, whatever you use to authenticate and authorize. It enforces usage quotas and rate limits, and it can transform API on the fly without or with code modifications. Then we have the Azure portal, which is the administrative control plane where you configure your APIs, and then the developer portal where you publish the documentation and developers can test the APIs. So in our scenario, we will leverage a very specific way of using the API management gateway, the self-hosted gateway. So you can host the gateway as a container wherever you want, and still benefit of all the management and DevOps capabilities of the Azure control plane, okay? But it will operate inside your environment. Okay, and we substituted the previously used Nginx controller with our self-hosted gateway. If we take a look at the configuration of a self-hosted gateway, let me bring this up. Well, I do not want to get into the details of how you configure the self-hosted gateway. This is a script that is already provided for you by Azure API Management, but you have to do something more because the self-hosted gateway is unaware by default of Dapr. In the same way we did with one of the application of our solution, the order service, and we did the same in Nginx, we have to decorate or annotate the deployment of the self-hosted gateway with the Dapr configuration. Let's look at the Azure API Management Service. This is the Azure portal. I have a bunch of APIs that I created that will look further in detail in a while. Just let's look at the gateways. So I have a gateway which is running into a Kubernetes deployment. Well, it's running in my Kubernetes cluster that I previously showed you. So just to recap of what we saw from VS Code and the portal. So we have an API management self-hosted gateway in the AKS cluster where the application, the Dapr application is running. We had to change the default deployment so it becomes aware of the Dapr ecosystem, and I also specified to use the same tracing configuration. So hopefully when we test it, the APIs, we will see that all the data, all the telemetry data is flowing through OpenTelemetry to Zipkin. Nothing more than this. Once we enable the self-hosted gateway, we become able to use 3 transformation policies that are the core of the Azure API Management integration with Dapr. So the first one is the service invocation policy. By using this policy and specifying that the backend is Dapr, and you can expect that this means that the backend is the sidecar running in the self-hosted gateway, then you have to just describe what is the name of the application, the Dapr application you want to reach, and the name of the method you want to invoke. And this translates to the target URL that we are familiar with. So localhost and the default port of the sidecar we use, this will be translated into the invoke to the app and the method. And I used it to create the order API. I wanted to show you also the publish and subscribe policy, which is the second transformation policy you can use with Azure API Management. So I thought about a potential use case. So bear with me. Let's say I have some external systems, okay, that should be able to send orders to my existing application without the need to go through the verification steps that are provided by the order service. It's a stretch, but it served the purpose of showing you the 2 different use cases. And this will enable me to create an API that looks like a synchronous API from the outside, but instead it uses the publish and subscribe building block of Dapr in the backend. So let's go back to the Azure API Management portal, and let's go back to the APIs. I already described it, but it's better if we take a look at it. So I have all my APIs here. I have also other tools, but in the post order API for the request that reaches /order, I specify the set backend service, and I'm sending the request to order service and the method order. It's a little bit different, the configuration for post order direct or /order direct, because I'm not invoking a service, but I'm sending a message with the topic on order submitted to the component configured in my Dapr environment named common pub sub. And nothing more. There is nothing more than this that is necessary to at least provide this scenario. If we switch from the previous example in which I use Nginx, well, as you expect, nothing really changes. So with order, I have the very same payload. We'll just send the request to the API management. This APM Dapr is a host I configured locally. Let's try the same with the order direct so we can see both requests in Zipkin and see what is different. Okay, this has been a little faster because I use publish and subscribe. If we go to Zipkin and let's go back and find out if there are more traces collected, and yeah, we have the previous one which started from the Nginx ingress, but now we have two other ones. So let's take a look at this one. So API Gateway is the name I gave to the self-hosted API management gateway from the Dapr perspective. And here we see that the call has been performed using the service to service invocation with order, and then everything from here is similar to what we saw before. So you see that all the activities are considered as span, and as long as all the communication go through the sidecars, you will gain full visibility. With Zipkin or with any other analysis tool. Just to see what really changed with the order direct. Well, order direct is using publish and subscribe, but is sending to another service, and there is a slight elapsed time from the completion of my operation, the self-hosted gateway sending to the sidecar, and the message being received, which is the purpose of using an asynchronous message. And from here on is pretty much the same. So hopefully this gave you a glimpse of the capabilities that the integration with Azure API Management provides. And with this, I could protect my APIs, for example, integrating Azure Active Directory, validating tokens. I could provide different level of services to my customers. For example, I probably should not give access to order direct to all of my customers, but probably to just systems I trust and that I know that performs the other validation. This is just an example, but it suits my intention to give you an overview of the Azure API Management integration capabilities with Dapr. There is one last transformation policy, which is the output binding policy. for which I do not have a demo because my application didn't already use it. So with the output binding policy, I could use one of the output binding components of Dapr and translate requests coming reaching my APIs, for example, in payloads being sent to a Kafka stream or placed into Azure Storage or Event Hub, whatever. And considering we should have few minutes left, I would like to give you a view of what I mean by component by showing you the Dapr dashboard. So here I have all my application running in the cluster. So I have the Nginx ingress, and I also have the API management gateway that we just saw. If we go to the Dapr components, the common pub/sub is the publish and subscribe component we just used in the order direct API, and it is of type Azure Service Bus. So it relies on an external service in the cloud, living in the same Azure region to do all the important operation that a messaging system like Azure Service Bus is capable of doing. And here I have many others that, for example, persist on Cosmos DB, the state of information, and etc. Okay, so in this session, I hope I gave you a quick overview of what Dapr is, its objective, and the base constructs in Dapr. I showed you the architecture of a sample application, and we discussed how it leverages Dapr. And then we'll learn how we can expose Dapr application, Dapr APIs via an ingress controller. Then we saw how we can use Azure API Management to compose, transform, control, and potentially even protect our API thanks to the direct integration with Dapr. So here I have some resources that I suggest you to reach for better understanding how to use Dapr, and few samples on Dapr and Azure API Management that I found useful. You can find the sample application in the repository of my book. I will soon write an article on integrating it with API Management. And here are my contacts. Now I'll switch to see if there are some questions. Let me see.
Yes, there are
Thank you.
2 questions for now.
Okay, thank you very much. Okay.
Can you read it, or
yeah, I can read it.
Okay.
So does the application access to Dapr component using REST API on Dapr Sidecar? Thank you. Yes. So you have 2 options. You can, from your application, you can tend to do what I showed. So rely on HTTP to reach the API. Is the simplest one, is the most understandable from my perspective, but you can also use gRPC. From a sidecar to the other sidecar, for example, in service-to-service invocation, the communication is always gRPC. You do not have to care to worry about it. The consideration on is it necessary? What is the advantage of using gRPC also in the shortest leg of interaction? Well, probably we can spend half an hour arguing in favor or not. There are surely some scenarios in which, if you have to do thousands of requests to the sidecar, the compound benefit of reduced latency by using gRPC gives you back the investment of using gRPC. Yeah, absolutely. Can we download the complete solution shown in this presentation? Yes. Here is the link. You know, there are different stages of the solution. So at chapter 8, there is already a lot. You can even do not care about how it has been made, because I use .NET, but it really doesn't matter what language do you use in Dapr. Dapr works with any language, even the language that do not exist already, because future languages, as long as they can interact with HTTP or gRPC, will be able to use Dapr. So, but you can take this sample, and there are deployment scripts that count on you creating the containers and pushing it to container registry. But I also provide deployment scripts to use the already available container images on Docker Hub, so you can just replicate the same environment. Yeah, okay, also another one. So does the Azure self-hosted API management replace the ingress controller? Yes, that was the intention. So I started my journey in Dapr from the Nginx, and for me, it's perfectly fine if you want to use it. But I feel like that if you have a front end, Nginx is more than fine. Once you want to directly expose APIs, Azure API Management is my tool of choice. And with the integration, you can really build transformation, etc. Another question is, does Dapr well, in Dapr, the redirection of the request to the correct pod? Yes. What Dapr provides is service discovery. So your application, which could be using SDK or not, okay, if it calls service-to-service invocation and like the API management, okay, so I'll bring back up the API management part. Okay, so here I'm using the service-to-service invocation. So the API gateway will ask Sidecar to reach the order service, and then once you find it, call the order. It will be the Dapr Sidecar responsibility to understand on which host, therefore on which pod, the order service is being exposed. Okay, and it's also the reason why I do not have to care about services in my application. The services will be something that Dapr creates for me and will use underneath. I do not need to care. It's one of the great advantages of Dapr. Okay, if we wanted to change the DB from another question, if we want to change DB from MySQL to MS SQL, would I have to make changes? No. This is, let me see if I have a configuration, hopefully without secret, because I'm not that good as I tend to be. Yeah, let's hope this one does not have secrets. Yeah, it does not have. Okay, so here is the component named order store, which my order service is using, order service, order store. And this is going to keep constant over time. But if I run it locally, I tend to use Redis. This is the deployment on Kubernetes. Therefore, I chose to switch from Redis to the type state.azure.cosmosdb. And that's all I needed to do. Obviously, there are far more details because different components might have different level of service, but they all need to provide a common set of capabilities in order to be considered a valid component for Dapr. And obviously, as you expect, I always think about Azure. But there are plenty of generic components for state store, publish, subscribe, and the input and output binding that I did not even mention today. Let's see if there is another question. I see a new one. Do we have time?
No. Yeah, we have a few minutes, okay. But there is no other questions.
Okay, so I'll move. So just to thank again the sponsor that made this event possible, and let me restate. If you want to know more about Dapr, connect with me on LinkedIn or on Twitter, and go to Dapr.io, etc. Thank you very much.
Davide. Thank you, Davide. Thank you to you, and I will look at your book because it could be very interesting. Dapr is a very interesting tech. We can say could be useful in microservices application, but also not. I think maybe could make light development of services in general. So
yeah, absolutely.
Could be it's very it's now time to production because I think last year Dapr
Dapr is at 1.12, so it reached GA on early February.
Okay, this year. Okay.
Yeah. And yeah, there are many.
We can use it without problem.
Oh yeah, absolutely. There are many customers, many contributors. There are some case studies from Zeiss, the maker of lenses, that use Dapr for their critical order management application. It's a public case. And then you have customers that contribute heavily to the project. For example, Alibaba that use Dapr for creating services that are used by their own.
This is nice. This is open source power.
Yeah, absolutely.
We have a last question. Let's say, wait.
So to talk with I'll read it. So to talk to the sidecar, the data structure has to be passed in source code is always the same. Yes, absolutely. So as I come from the .NET background, I always start looking at things from the SDK. With Dapr, I learned, maybe it was obvious for you, but I learned that the SDK is not the first choice for many customers, many development teams, if an API is already available. And in fact, you can do the same things I'm comfortable to do with the SDK by just interacting with the HTTP API. And it's just sending a payload to the sidecar API. So it will not change if you switch from on-premise to cloud, to edge, or if you switch, for example, state from Redis to Azure Cosmos DB.
All right, we can do it. We did it. Now it's time to lunch. So thank you, Davide, again. Thank you to you. Oh, wait.
Another one?
Yeah. At the end, people, let's shine.
No one was to go and have lunch. So can Dapr deal with stateful sets? Oh, well, this could, we could spend a lot on this because I did not discuss about how Dapr can influence the way you develop microservices. I really briefly touched it at the beginning, but the sense is that Dapr enables you to always have to create microservices that are stateful without having to manage the state, because it makes it very simple to take your state and put it aside on any state store. For example, with Actor, you can have a very complex structure of behavior, code, and data live together and keep data in memory. And once they are not needed, they go out of the memory. Once they are needed back, they come back to the memory in a transparent way. You don't see anything of this. So I think, yes, this will need larger discussion on how do you see stateful sets being used and etc. So
Okay, I imagine. Thank you again. Thank you all,
thank
and
you.
have a good lunch. See you in the afternoon.
Thank you.
Bye bye.